I used the verbal visual word association and the MIP, most important point. I think it was good to start, because it was a new strategy, I started with a model that the groups worked together in, and just for about 10 minutes, and had them go through it together. They're thinking together about creating a definition based on our past unit, just the prior unit before. So something they were very familiar with. Then we had a share out and had a student come draw their visual representation for a proportion, which had many options. So there are lots of ways for them to have success on the VVWA as the method of learning the strategy itself. So I wanted to use that as an opener so that they would have some mastery on the strategy and then feel confident enough to apply it to the terms and relationships we were discussing. The verbal visual word association is a little bit long for a title maybe, but it is a very handy strategy. The one I want us to practice on right now is on proportional relationships. The title goes in that upper left-hand box, and that's all. So I kind of tried to make mine attractive and pretty. Proportional relationships. We've been talking for many weeks about proportional relationships. So I want your group to discuss and decide what is the definition of proportional relationships. Think about all of the things we have used proportions to solve problems for and about, and how the presentation was looking under characteristics, the characteristics of proportional relationships. This is everything we've done for all the weeks since we've returned from Christmas. So I would like for your group to come up with a definition, special characteristics you can list in the box there, and then I would like a visual. Think of all the things that you could draw to represent an example of this category, proportional relationships. What are you thinking about the definition for proportional relationships? Equal. What about cross products? What are we finding cross products? What is it that you're finding cross products of?
It's
Of what?
to tell the ratio.
To tell if it's equal, but I think he said another word. All of these things are important, so think about what a good definition would be for a proportional relationship. What picture do we have? What visual? Let me see your visual. That is how we solve proportions or test proportions, but what about some of the things we solved with pictures? We drew so many things, remember, and I had to caution you not to critique me so badly on my drawing abilities. Can you draw anything with a shadow?
I can't find the definition.
That's good, because we didn't make our book anyway.
I did. What are the characteristics?
No, we're going to use our working knowledge, Cherries.
I don't remember this.
Our brain knowledge.
There are so many things that you could have put in this verbal visual word association table. What is a good definition, a working definition? Notice I did not want you to look up a glossary definition. So who will share with us their definition right here? Trista, everybody listen to Trista.
Equations that two or more ratios have.
Equations, repeat.
An equation that two or more ratios.
All right, an equation that shows two or more ratios are equal. Cross products. Who wrote something about cross products in their table as a characteristic, and maybe even part of a definition? What do we do with the cross products, everybody? What does it find? It finds if the proportions are equivalent, and it might also find an unknown, like if you have a variable in it. Those are important characteristics. What does your visual look like? Who will share with us something you drew? A lot of people had the groups did one thing. Dylan, what did your group like to say about the visual?
Two big, one big and one small triangle.
Would you call your group back there, Barron's group? Under the visual, what did you have drawings of? Shadows. Oh, yes, we did a lot with shadows. What was that called, everybody? Measure it, or it was indirect. All right. Does everyone understand the process of going through the verbal visual word association?
I wanted to try the verbal
visual word association because as a habit I kind of had defaulted to the Freyer model frequently, and I didn't want it to become stale for the students. But then the visual aspect is what I was adding oftentimes to the Freyer, so I thought this was actually a better fit, and I was eager to try it. So that led to that for our angle pairs, and the visual part is really important for distinguishing for this lesson the 3 different types of angle pairs. And then for the students to show that they knew what the lesson was about, I chose MIP as a closure so they could identify in a single statement the most important part about the angle relationship.
So today I want to transfer what we have just now learned about this strategy, the verbal visual word association, to our new unit in geometry. Yesterday we began talking about pairs of angles. Who will tell what one of the pairs of angles names we talked about was? Complementary and supplementary. Right now I'm going to give you an attractive VVWA that I made for you, and I want each of you to start filling in complementary and supplementary. We need a definition. If you need your notes, open back up to your notes. Please put your name on that. Characteristics and the visual. I would like to hear your group talking about what these look like and what their definitions are, as well as their characteristic. I notice you have 2 different examples, or do you?
That's just one example. It equals 90.
Okay. Are those attached or detached? Detached. So is that a characteristic?
Like, how would you write that out? Detached angle?
Can the pairs be separate from each other and we realize based on their measures that they equal 90? So that's a characteristic, as well as might they be, what's the alternative if they're separate from each other? Could they be together? Yeah, which means they would share a vertex. All right, so I'll let you get a head start on complementary angles, and I had Emily go to the board. 2 angles whose sum is 90 degrees. What do we know about 90-degree angles, everyone?
That they make right angle.
That's a right angle. Can it be any other measure than 90? No, not 89, not 91. It has to be exactly 90. What would the picture for that look like? I'm going to ask Beatrice to come draw her model that Beatrice chose. Was that from our notes yesterday? Who also has that in their visual block? Do most of us have that in our visual block? I think she does right here. Are these angles attached or detached, every person? Detached. Do you think that's a characteristic we need to write? Yes. The angles may not be attached. That's called separate, or they might be detached from each other. If they're detached, we're going to rely and focus heavily on their number of degree measures to make sure they equal what number? 90 degrees. Is there another way that these can occur? Attached. Who will come draw what a model would look like if they shared a ray? And I'll go ahead and put that under characteristics. They might be attached. Another word for attached would be joined. So I'll just put joined behind. Moving on to supplementary angle pairs. Taylor, tell the class what supplementary angle pairs are while they finish this one. 2 angles whose sum is 180 degrees. Come around and we'll put our final result for supplementary very quickly. Supplementary. 3 minutes. Let's go. All right, so what are the characteristics, Taylor, that your groups decided? You and Beatrice have characteristics. They may be attached or detached. So when we say they can be attached, then that means they also, maybe they won't be. So those are good. Do you have both visuals for that? What it looks like when they're attached together and when they're not? Okay, I'm not sure Barron does. What do we say is important to know about supplementary angles? I think the definition is friendly for this one. What do we say the definition is? All the people tell it. 2 angles whose sum is 180. All right, so here's our sum. Who will come draw the visual for Supplementary angles.
Jordan, you haven't done yet.
Okay, Morgan. While Morgan's drawing the visual for that, what do we have under characteristics? How about Barron's group? Somebody from Barron's group, tell us what one of the characteristics would be. They may be detached, which means separate from each other. Give us another characteristic, Stone's group. They might be attached. Every person. Could we have two right angles in this? Because I'm predicting, based on our visuals, that no one drew two right angles connected. But can they be right angles? So they may be. Is that something we need to write down as a characteristic?
Yes.
I think so. I think that'd be a fine place to put it. Morgan has not drawn two right angles. What has she drawn as her model? An acute and obtuse. Do you think that's the most common way we'll see it presented? Probably so. But I don't want you to think that it cannot be two right angles. So I think that would be good for every person to write under characteristics.
Strategy really laid out the different components of the relationships for angles, because it separated the definition from the characteristics of the angle pairs, and then having a separate VVWA for each of the three angle pairs gives them something to refer back to, not only in words, which as we know don't always help solidify the differences, but the characteristics, and then of course the visual. So I think it was just a perfect way to distinguish between the three angle relationships. Adjacent angles. Has anyone ever heard of adjacent angles? Raise your hand. Angles. They have to be in the same plane, but they will share a vertex. What's a vertex? Tell your group. They're going to share a vertex and one of the sides. We know the side's name is a red. It's a little bit easier with different colors. Does this make sense based on the definition? Is this a good visual? Does it match? Kennedy, if we look, we're looking for two angles that share a vertex and one of the sides. So they share a ray. Now, may I ask, does this just occur just in angles, or can this adjacent angles, can this be related where lines are concerned? So it can appear in lines, right? So we're going to write that. Intersecting lines. I'm already in pink. I'm going to draw a pair of intersecting lines. It's a little bit harder to see, Greg. Over here on the two angles, we can see they're adjacent. Angle number 1 and angle number 2. I'll number it for you. Angles 1 and 2 are adjacent in this first figure. Over here, if I numbered our angles, 1, 2, 3, 4, what will be adjacent to angle 1?
1, 4.
1 and 4, because they share this ray right there, just like AJ said. Only share, what do you think? Look at the word. Vertex. Angles that share a vertex. Do they share a side?
Yes.
If they shared a vertex and a side, I think we just learned the name of those angles. Those are called adjacent. Vertical angles, angles that share a vertex. What do you think that might look like in our visual? I don't want to share a side. I want to share a vertex. So I'm going to need to draw another angle that has a vertex right here. So I think I'll draw this angle coming over there. There we go. They share a vertex. Only a vertex. Under characteristics, these are unique right here because they are congruent measures. After you write this last part and your group has the visual, I want you to look at the very last statement. And this is a study note for us. This isn't an assessment, but it has MIP at the bottom. I want your group to read that and come up with your one statement. MIP at the bottom. I think using the VVWA, I was surprised. I think students are much better than I am at making drawings and diagrams, and they were, and that part was right. But I was surprised that they were hesitant on
listing the definition. They just were afraid to say on their own, even though they knew and they would say it out loud. They didn't want to commit to writing it. And I think it was Miranda's group really were struggling on the definition. And I was like, but just be confident. And but no, they wanted to look it up in the glossary. We're trying to get away so that they have ownership of what it is. So I was surprised that was the fallback, because for me as a student, the visual portion, actually making the drawing, would have given me pause to look around. Is mine adequate enough? But they did a good job.